So we try to use the clonable, right? So we mark the circle as clonable. So to mark this, to make sure that I can clone the compatible circle, which I have an access to .clone methods. But now .clone actually it has protected access in java.lang.object. That means access modifier of clone. If you check java.doc, so let's go and check java.doc for object java.doc in Java. They should have the method name clone, and this is protected right there. So this resides in the package java.lang, and we already know the scope, right? When it's reside in .lang, you don't have an access when you are in this package. In the package com.util, different package. You don't have an access to protected modifiers. So that's why it's complaining that clone has protected access in java.lang.object in different package. So if you want to mark this as clonable already, the compare level circle and in package com.util, then in order to access to clone, then you need to override them. Override. We already know that we can override the clone methods because clone method is, let's return object, is the parents, right? Method of is the method of object which is the parents of comparable circle, and we can override that clone. So what we want to return, we just return super, right? Dot call the method to clone, right? So what do we want to clone? Pass object in clone. So object right? We call clone. 1 second. We need to pass object. When I call clone, I actually want to return. We actually just do clone.clone means just return the object of this to the new object, clone circle. Then we don't need to pass in parameters. Now it's complaining that this is check exceptions that we learned, so we have to handle it. If we use this method, we have to check exception. So we have to add the handle it. Try to clone. If there's a problem with clone, then we throw exceptions. Right. So a print stack trace member just print the error. So we can just also say print that. You can do system.err for errors. It's just like system.out, but it's just print out the red text instead of black, like that. Error cloning the object, something like that, right? Alright, so return statement. So since it's good return, so return, if we can clone return. Now if we cannot clone, what would you like to return? So just caching errors. Return null. So we print out the errors, print stack trace, and we return null. We cannot clone. Then this is going to be null. Now, this should be happy at this point now, so run this. Now there's no problem. Now we're going to test that if the object is actually cloned. So to test that, we need to add the code. Like one is if clone circle instance. We can use instance of. Right. So I can just print it. Right. System.out.print. And just say instance of. Right. So clone circle is instead of. So let's say it's true or false. instead of the object here, list of circle 0 that I just cloned. So it's going to return to if it is say unknown class. This is not a class. This is just an array. This is an object of list of circles. So let's not do concatenate yet, because this is an expression. So list of circles 0. Actually, this should be instead of the comparable symbol, the one we want not to list off, right? Because we want to see this is an object of comparable symbol instead of, and we're going to compare if it's equals. That's the next one. So comparable symbol. That's just to check. The next one is, this is an expression, we cannot contain it. So the next one is, we have to make sure that we want to see if clone circle equals to the list of circles at the index. If it is equals, that means it's cloned. It should return true. Okay, so clonable, and we implement the equals. We have to implement how to compare equals inside the circle class, which we take the object and compare its own radius to the object of the radius to compare. Now run this. So both of them are true. That means clonable is successful. So let's see, for example, if I took off clonable in first out, so that means this should not be able to clone. If I run this, it should return false. That means this radius is not instead of comparable circle. And that's a problem also, because it's not an object of that, and clone not support. Right? See, we try to clone, there's a problem. So if we want to clone, in the first clonable is important. So just like the same principle of comparable, right? For compare to, if you use array.sort, it has to be comparable. If you want to clone, it has to be clonable. Now you can look at an example of clonable in-house. This is just implements clonable, comparable house. So that means we has to override clone, and that's how we implement clone, super clone. If there's problem, return null. Otherwise, return itself clone. Shallow versus deep copy. So when you do house, new house like this, this is create an object of house1. And we can do house1.clone, right? And it casts that. This return object casts as house, so house2 is house1. So look at it in terms of memory. House1. So we reference to the number 1 in the memory, which is an int doubles area, when build reference to the date again, which is an object of the date class. House2 equals to house1.clone. So house2 is going to be a copy of house1. So same reference. So this is called shallow copy. Now if we do look at deep copy. So deep copy, like instead of the reference to when built is also a reference to the same date, pointing to the same date. We actually have its own when built contents. So this is called deep copy. So reference to an object of the date, own state. So interfaces versus abstract classes. Data must be constant in the interface. An abstract class can have all types of data. Each method in an interface has only a signature without implementation. An abstract class can have concrete methods. With the implementation we call concrete methods. So let's do comparison of the table. You may see this on your test. Comparison here. So abstract class, you see that variables has no restrictions. Interface, all variables must be the final constants. You don't declare non-constant variables in the interface. For the abstract class, constructors are invoked by subclass through the constructor chaining. An abstract class cannot be instantiated using the new operator. For the interface, no constructors. An interface cannot be instantiated using the new operator. For the methods, abstract class, you can have concrete method, which is implemented method, or you can have abstract method, which is just a header, method headers. Both of them, no restrictions. But for interface, only have the abstract methods, and they are public, which you're not required to define public keyword. It can be omitted. Now let's look at all classes share a single root, the object class, but there's no single root for interfaces. Like a class, an interface also defines a type. A variables of an interface type can reference any instance of the class that implements the interface. If a class extends an interface, this interface plays the same role as a superclass. You can use an interface as a data type and cast a variables of an instance type to its subclass, and vice versa. Suppose that C is an instance of class 2. C is also an instance of object. So you see class 2 implements interface 2-2, implements interface 2-1, and interface can be inherited too. Like interface 2-1 extends interface 1. Interface 1 extends interface 1-1. Right. Actually, interface can be implemented, right? Interface 1 implements interface 1-1 and implements interface 1-2. So these are the symbol implements. Interface 2-1 implements interface 1. Now object, class 1 extends object, class 2 extends class 1. So C is instead of class 2, C is also instead of object. Yes, for sure. Class 1 interface 1, right? C is also an instance of class 1. C is also an instance of interface 1, interface 1-1, interface 1-2, interface 2-1, and interface 2-2. Caution, conflict interfaces. In rare occasion, a class may implement two interfaces which conflict information. This type of errors will be detected by the compiler. Two same constant with different values, or two methods with same signature but different return type. So conflict interface can be occurs but it's rare, right? When implements two interfaces, the class implements two interfaces.